I got this Bluetooth speaker for repair. The owner says that he accidentally connected to 240 volts power and it just stopped working. I wonder why. The speaker claims it has 3500 watts PMPO. Of course, no one knows how to calculate that. And also says that it has 200 watts RMS. That is easily to see. So we are going to check it. First of all, I won't just replace the fuse and assume everything is okay, because if I replace the fuse and turns out something else was born inside, I can damage other parts or the same fuse again. I will open it, removing these 8 screws. Then carefully disconnect the speaker wires. As you can see, there were other wires already disconnected. Somebody else attempt to repair that. I think it's not worthy to repair this speaker because, as you can see, the box is very cracked and many things are disconnected, but it is good for make some YouTube videos and experimentation with it. Now I will remove the fuse and check if it's burned. I hope it is burned down, because if it's not, maybe it got something else very badly damaged. But on visual inspection, it seems like it is burned out. I'm gonna check it with the multimeter anyway, just to make sure. We put it on diode checking or short circuit checking. It's not beeping. Luckily, it has a replacement fuse already here, so I'm going to check it to see if this one is okay. I cannot pull it out. It is working. So I put it out of the box and put it like this in order to install it again on the fuse box. Let me just figure out which one is the correct side. I'm not very good at this. Okay, looks like this is the way it should be. Now that the fuse has been installed, I will check to see if something else is in short circuit or open circuit, something like that, before I connect it to the power again. This is the main power to the transformer. This is for an external speaker. And these 3 wires, 2 blue, 1 black, is the main power for the amplifier. As you can see, there is another pair of green wires and white ones. Seems like it has other 2 power supplies for other components. Let's see later how it is split. Okay, I have moved it. Let's crack this tie. I know with a pair of scissors could be easy to do this, but I don't have any here and I don't want to go for them. Here you can see a bridge rectifier. Let me see if I can show you very briefly what's inside. This old board is the power supply, 3 power supplies. This is the main power supply for the amplifier. Also, it seems like there are a few voltage regulators. I can see a 7812 voltage regulator. That is 12 volt power supply regulator. So let me check to see if I can find some short circuit and also if the main transformer is working. This is a symmetric power supply, so the transformer has these 2 leads. Each of them is 31 volts with respect to the center tap. And it seems to be fine. Also, there are the other 2 power supplies. One already we see that it is for 12 volts, something like that. And since it has 3 wires, it means it is a symmetric power supply, so it has to be minus 12 volts and plus 12 volts. The speaker has 3 main components. This is the MP3 player. It has the USB reader, the card reader, and all that. I think even AM/FM radio too. Then it has a 4-channel mixer, 2 XLR, or 1 or microphone inputs or instrument inputs, and 1 stereo input. And also it has a 100 watts mono amplifier. I checked the transistor already, it is for 100 watts maximum. And lastly, it has, like what you say, 3 power supplies. One for 12 volts for the MP3 players, another power supply that is symmetric for plus minus 12 volts for the mixer, and the symmetric plus minus 30 volts for the amplifier. This is the back of the plane. Here you have the circuit for the MP3 player, then the 4-channel mixer. As you can see, these are independent circuits. Maybe you can buy it separately and assemble on a speaker. And here you have the 100 watts mono amplifier and the main transformer. This transformer has 3 secondary coils. One for the amplifier, one for the 12 volts of the MP3 player, and another for the 12 minus plus volts of the mixer. So let's connect it to the power and see if it works. I'm going to send something via Bluetooth to the Bluetooth receiver. In this way we can test that the Bluetooth player, the mixer, and the amplifier is working. But I have no sound. Let me check. There's something weird with the green LED from the mixer. Seems like the MP3 player powers well, but the mixer, the LED green power on the LED is not steady. It is like blinking. I don't know if that's a problem that maybe burned down some of the operational amplifiers, or maybe the power supply for the mixer is not working. I'm going to check the power supply. It should be receiving plus minus 12 volts. So I put one of the leads on the center tap and the other one of the streams. I have to read minus or plus 12 volts. And I have nothing. Nothing. Okay, the power supply for the mixer is not working.
Sí, ya bebé.
Even that, there was some blinking on the LED, so maybe there's a residual power. I'm going to test if the power from the transformer is okay. I have some voltage here. Okay, I have something. I do have AC. As you may know, a power supply has the AC converted into DC, so the AC part is fine, and the DC part is giving me right now 6 volts on one end and nothing on the other end. This could be two of these problems. The bridge rectifier that converts AC from AC to DC, and the other option will be the voltage regulator. It has two, one for the positive side and one for the negative side, so I will have to check them both. As I mentioned, the power supplies convert the AC from the power outlet into a DC, a lower DC. From here we have two outputs and a central tap. It gets rectifier into DC by this bridge, diode bridge, and then regulated with two voltage regulator. Right now here, as you can see, those four are surface mount diodes. One of them maybe is damaged, so I will have to remove the four of them because I don't have how to replace just one of them. And there you can see also the 7812, so the one behind that should be a 7912. We have the plus minus 12 volt power supply for the mixer. Most of the mixers you will find that it has symmetric power supplies because it uses operational amplifiers to mix the different inputs. Looks like the minus part is fine, so the problem must be on the plus side, the 7812 voltage regulator. Okay, so I will remove the voltage regulators and also the bridge rectifier and replace it with another bridge rectifier. Since I don't have the surface mount diodes, I'm going to use a generic bridge rectifier, those that came in as a single package. You just need the two inputs from the power supply from the AC transformer, and it will give you the two outputs, the plus and the minus. And from there, as you could see it in the diagram I showed you before, you can split it into positive rail and the negative rail and a center tap. I'm going to replace the capacitors also because I'm not sure if they are okay too. Okay, this is not the best way to test a voltage regulator, but it can give us an idea. I put it in diode checking, and as you can see, if I put one of the leads on the tap and test the other pins, it will beep sometimes and turn off. That means that something is working there. But if I put it in the 7812, all the leads give me like a short circuit. So it means something is burned inside or something is in short circuit. Because I tested every one of the three pins and all of them give me a short circuit with reference to the other pins. 7812 to replace it. So we are in good shape to get this moving. Also, I'm going to replace the capacitor as I said, just to make sure. Now, if I test this voltage regulator, let me see, just check again to see and to make sure that I'm replacing the correct one. Can you hear that? It beeps and then it stops beeping. That means that something charged inside and it is working because it automatically stopped the beeping. Not with the burn one that didn't stop the beeping, so it is just a short circuit. So I'm gonna clean up the board and install the components again. So this is how it is now. Those were the place of the surface mount diodes. I replaced it with this pack of bridge rectifier. Replaced the two capacitors and also a voltage regulator. Now let's see if we have the minus and plus 12 volts. Okay, 11 volts, that's okay. I assembled the speaker basically, and now we have the MP3 play. I put it first with this cable. Looks like we have to clean up the potentiometers on the mixer, but at least we have sound. It means the mixer is working. The power LED on the mixer is steady green, so it means that we did fix something. Let's check now with the MP3 player. I'm going to use this free audio from YouTube so I don't get copyright strike. Volume for the MP3 player is working. Main volume is working too. The masking tape here though is not working. But seems like everything is working now, so we could say this is a successful repair. Let's look inside again. There you have the replaced chips, the replaced transistor or voltage regulator. I'm going to put a tie or something like that so we don't have the cables moving around and making noises. Again, just look at the box. It's not much improvement you can make with the quality. So I told you that I put out the transistor for the main power, and it is a TTA J943 from Toshiba. I don't know if that's really from Toshiba, but that's what it says. And this transistor is rated at 200 volts. So I don't think the speaker has 200, and it has this for external speaker of 8 ohms. But if you look at the board, it's not like it has 2 amplifiers. This cable is connected in parallel with the main speaker. So it is sharing, it is a parallel connection between the 2 speakers, so it is not 2 amplifiers. I really want to be posting videos more frequently, but my work had me very busy, and it is difficult for me to do videos. There is so much I want to talk to you about, so many projects and so much information, but we eventually gonna get there. For the meanwhile, thank you and be safe.